The factorial of a number n, written n with an exclamation mark, is the product of every whole number from 1 up to n. So 5 factorial is 1 times, 2 times, 3 times, 4 times 5, which is 120. It grows very quickly. We want to compute it for any n by multiplying our way up. The approach is a simple running product. We start with a result of 1, because multiplying by 1 changes nothing and gives us a safe starting point. Then we walk from 2 up to n, multiplying the result by each number along the way. When we reach n, the result holds the full factorial. Starting at 1 also neatly handles 0 factorial, which is defined to be 1. We begin with a result of 1. Then we loop I from 2 up to and including n, multiplying the result by each I in turn. If n is 0 or 1, the loop simply does not run, and the result stays 1, which is exactly what we want. At the end, we return the product. Let's build it live and watch the product grow. Start the running product at 1, which safely handles 0 and 1. Multiply the result by every number from 2 up to n. Return the accumulated product, which is n factorial. Now let's test it and hit run. Zero factorial and 1 factorial are both 1 by definition and because the loop does not run. 5 factorial is 120 and 6 factorial jumps to 720. It grows fast. The flow is a plain accumulation. Start the result at 1. While I is at most n, multiply the result by I and step I up. When I passes n, return the product. We do 1 multiplication for each number from 2 up to n, so the time grows linearly with n. We keep only a single running product, so the space is constant, though the number itself gets large very quickly. Keep 3 things in mind. Both 0 factorial and 1 factorial equal 1, and starting the result at 1 gives that for free. The range must go to n plus 1 so that n itself is included. N factorials explode in size, so in many languages they overflow, though Python handles big numbers gracefully.